let's start. So
Yes, sir.
let's start by calling these numbers. Let's go. First one.
27.09,
Very good. Second one.
27.90,
Next one.
207.90,
Good. Last one.
207.09.
What is this question about?
Decimal, sir.
More than that.
Um, sir, order in decimals,
No. What's that?
place value.
Okay. So this question is testing if you know your place value. All right.
Yes, sir.
44.2. And we're going to subtract from that 2.7. So we're going to set things out like this. Help me to subtract now. So can I take 7 from 2?
No, sir.
What will I need to do?
Borrow.
Okay, so we're going to take 1 from the 4, leaving us with 3. This one will make 12 here. 7 from 12 will leave me with what?
4, sir.
No, sir.
So, 7 from 12. 5, sir.
Okay, because 5 and 7 would make 12. Decimal
12.
point under decimal.
Point.
And 2 from 3 will leave me with?
1, sir.
Because 1 and 2 makes?
3, sir.
And what will I do with the 4?
Just write it back, sir.
Okay. So when I take 2.7 from 44.2, my answer is what?
41.5.
All right, very good. What type of problem is this?
Subtraction problem.
Of decimal.
Decimal.
Now we have a dollars and cents problem. So we're going to add $29.35 with $4.21 with $1.05 and 8 cents. All right, we could
Yes.
put some placeholders here to fill this up so it's easier for us to see. But this is still 8 cents. All right. So let's add 8 and 5 would be what?
Sir. 13, sir.
13 and 1.
14, sir.
14 and 5 would give us what?
19.
So we're going to write 9 and carry 1. So let's start with that one first. 1 and 3 would make?
4, sir.
4 and 2 would make?
6.
Okay, so we write our 6. Decimal point under decimal?
Point.
So 9 and 1 here would make 10. 10 and 4 would make what?
14.
Right,
Put
4
on
and
the
carry?
1.
So 1 and 2 would make what?
3.
So my answer will be what?
3. No, $34.69.
No, sir. $34.69.
Yes, sir.
All right.
Yes, sir. Dollar sign.
Yeah.
Sir?
I'm not certain what's happening there, so I thought. Okay, what's the value of the underlying digit here?
Sir, 20,000, sir.
All right. So 20,000. So if we had the 6 here, this is ones, this is tens,
Hundreds.
hundreds, thousands, and
10,000.
tens of thousands. So place value would say this is 2 times 10,000. This would be 9 times what?
thousand.
1,000. Or 4 would be 4 times 100.
400.
Or 5 would be 5 times 10. And finally, or 6 is 6 times 1.
Yes,
So
sir.
this is the one that they asked us. So 2 times 10,000 would be 20,000.
1,000.
9 times 1,000 would be what? 9,000. 4 times 100, 400.
100.
5 times the 10, 50,
50.
and 6.
1, 6, yes,
Okay.
6.
So this is the answer that we're looking for.
Yes, sir.
Mouse gone to sleep. All right. We're looking for the 20,000 because that's the underlined digit here. All right.
Yes, sir.
What type of problem is that?
Sir, expanded notation.
Okay. And place value.
Yes, sir.
Okay. So can we call these numbers?
Yes, sir.
Starting with this one. What's this one?
684,955.
And this and this one?
684,950.
What about this one?
6,840,955.
And finally,
60,840,955.
well done, sir. What type of question is that?
Sir, place, no,
Yes,
place,
it is a place value. It's a place value question because if you don't know where the place value for each of these digits is supposed to be, you will not be able to call the number correctly. And if you will see these same numbers in words and you can't match it to the place value, then it will be easy for them to trick you. All right, let's look at this. So we have here set F and set E. What is F union E?
sir,
What
2.
union mean?
Sir, union means everything included in the set.
Okay, in both of them. So we have what now? 2.
2,
Uh-huh.
3,
Uh-huh. So the 2, the 3 gone.
5,
5 is gone.
6,
6 gone.
7,
7.
9,
9.
10,
10.
11,
11.
15.
15. So what we had 6 over here, so and 6 over here, so why we didn't write it twice?
Because it's in the same, no,
Once it's in the universe, we only need to write it once.
once. Yes, sir.
So what would be the members in set E? If this is set E, what are the members of set E?
6, no, 3, 6, 7, 9, 11, and 15.
Okay, so 3, 6, 7, 9, 11, 11, and 15.
Yes, sir.
So what is the intersection? Your
Sir,
your headphone.
11 and 15, sir.
Your headphone too close. So 11 and 15. I hear a nice feedback loop. So 11 and 15.
Yes, sir.
All right, so that's good. Nine tenths and 300ths and 4,000ths is
Sir, sir, they are decimal fractions, sir.
yeah, but I want you to add them up and tell me what you get.
Oh.
What's 9/10 as a
Sir,
decimal? 9/10 as a decimal is what?
um, mm, so- oh,
9.
yes, sir, 0.9.
0.03
3
plus
0.04.
0.004. Add these, what do you get?
Sir,
0.934. Sir, how you get that? Let's look. 0.9 plus 0.03 plus 0.004. Add these together. Let's put some placeholders
sir,
in. 1, 2, 3. So 4 and 0, 4. 3 and 0, 3. 9 and 0, 9. Decimal point and a decimal point placeholder. Do we notice that these are the same?
yes, sir.
So my answer, when I add 9/10ths, 300ths, and 4,000ths, my answer is 0.934. Cool?
Yes, sir.
What is this in terms of
Sir,
our common fraction? I'll tell you that it's 10 columns across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 rows down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So
sir,
how
100.
many squares? Okay, so I'll have 100. How many have been shaded?
36, sir.
Okay, so write that as a common fraction.
36 over 100, sir. Or
Could we
30
reduce?
36%.
Okay, so we could write that as a percentage, 36%. Could we reduce this fraction?
Yes, sir.
All right, so we can start with 2, not true. 2 can go into
Yes,
36. How many times?
sir. 18 times,
18, good. And 2 can go into 100.
50 times,
Okay, so we could use 2 again. 2 into 18
9 times, sir.
and 2 into 50.
25.
25. All right. So we could say 9 over 25. Instead of using the 2, what could I have used? What's the highest common factor of 36 and 100?
Um,
How many times I use the 2?
sir, 2 times, sir.
Okay. So the highest common factor could have been 4. 4 into 36 would have been what? 9 times.
9
And 4 into 100, 25 times. Highest common
times, yes,
factor
sir.
would have been 4.
4.
As a percentage, this is what? 36%.
36%.
Which of these is odd?
21, sir.
21. Why is it odd?
So because the rest of the numbers end with a multiple of 2, sir.
So in the ones place, I prefer if you say in the ones place, any number that has in the ones place 0,
2,
2,
4,
4,
6,
6,
or
or
8.
8, those numbers are called even.
Even number.
Any any number that ends or has in the ones place 1, 3, 5,
5,
7,
7
or 9, these are odd
numbers.
numbers. So 16, even. 24, even.
Even
30, as we have the 0, the 4, and the 6, which means that it would be even. But 21,
4.
1 there. So this means that it is
Oh,
odd.
yes, sir.
Even numbers greater than 20 but less than 28. Which one of these would show that?
Even numbers greater than 20, but listen, sir, 22, 24.
All right, so you're saying this one looks right then.
Yes, sir. A, B, sir.
Why couldn't be this one up here? So what's wrong with this?
Sir, because it said even numbers.
So what's wrong with 23?
Sir, it is a even number because when 2 is divided
Let's say that
by,
again. You said that it's an even number?
no, sir, odd, sir, odd.
Okay. So it's an odd number. Because
Because when 2 is divided by 23, sir, it leaves a remainder of 1.
mm, no, I want you to say that the other way around. When 23 is divided by 2, it leaves a remainder of 1. Okay? And the same is true of what? 25 and 27. So we have all of these are what? Odd numbers. Here again, we have odd number, odd number, odd number. What did they ask for? Even numbers greater than 20.
Sir.
What's wrong with this? 22, 24, 26, and 28.
Sir, I can't see, sir, because Roger continue calling me, sir. Sir, my screen has gone.
If it says 22, 24, 26, these are all okay. They are even, but here we have a problem because in the original statement, it says that we need one that is what? A set with numbers, even numbers, less than 28. 28 is equal to 28. So we cannot use option C if we're labeling them A, B, C, D. All right. So option B, the one that you highlighted first, that would be the one that would have to use. Ready again? All right, until you get back, let's go with this. 10 over 12 in lowest terms is?
Sir, 10 over 12. Sir, 5 over 6, sir.
5 over 6.
6.
What did we use?
2, sir.
Okay, so 10 over 12, I'm using 6. 2. Now, you said I'm using 2. 2 into 10 would go 5
5
times. And
times.
2 into 12 would go 6 times. I end up with 5 over 6. That's the same
Yes.
as setting it out like this. So we're dividing the numerator and the denominator by the same factor. 2 into the 10, 5. And
5,
2 into the 12, 6.
6 times.
How do I know that this is in lowest terms though?
Sir, because There is no other number but one that can go into 5 because it is a
Excellent.
prime number.
Okay. So this is what we need to remember. Anytime we're going to lowest terms, the only common factor that they will have is 1.
Is 1.
All right. 45 out of 60 as a percentage is?
Sir,
How are we going to set this
fo-
out?
sir, 45 over 60 times 100 over 1.
0 will cancel 0. What I mean by 0 cancel 0? What does that mean?
Sir, sir, you are canceling by a power of 10, sir.
So I'm dividing both the numerator and the denominator here by a power of 10. Which power of 10 am I dividing by?
Sir,
Didn't hear you. Go again.
sir, 10.
Very good. So we were dividing by 10. So now we're left with 45 over 6. And that goes into, and we have 10 over here. What can go into both 6 and 10, or what can go into both 6 and 45?
45. Sir, nothing.
Oh,
No, yes, sir. 3, sir.
3. Okay, so 3 could go into the 6, and
2
3 can go
times,
into or 45 how many times?
15 times,
15. Very good. 2 now can go into 2 one time. 2 can go into the 10. What?
5 times.
5 times. Now we're left with 15 by 5 over 1 by 1. That's going to be what? 1. And 5 times 15 would give us what?
Sir, coming, sir. Sir, 102.
102?
Sir,
Check that
coming
again, man.
by 5. Sir, that's what I got, sir. Oh, sir, sir, wrong there, so, sir. Sir, me bring you 5, sir.
Oh, okay. So you see that we have to actually write it down and make sure that we are writing down the correct number and carrying the correct one. You ended up with
Yes, sir.
102 because you carried the 5 instead of carrying the 2.
2.
So this would be what? 75 over 1. Any number divided by 1 remains the same. They asked for the answer as a percentage. So this would be what?
75%.
All right, good. 87% as a common fraction would be?
87 over 100, sir.
Excellent. So this would simply be 87 over 100.
100.
4 hundredths expressed as a decimal.
Sir, 0.04, sir.
So we could say 4 over 100. We have two zeros there, so we're going to move 2 places. 1 place, have another 0, another place. So we end up with 0.04.
Yes, sir.
Okay, let's see. Which ratio is the same as 3 to 4?
C.
12 to 9? 6
No,
to
sir,
8?
C.
Okay, 6 to 8, yes, sir. So what I would put 8 over 6. I'd take my ratios and turn them into fractions and reduce to see if I could get this ratio, which is actually 3 to 4, as a fraction. It will be 3. Work on that microphone for me, please. 3 over 4. So let's reduce. What's the highest common factor of 8 and 6?
Yes, sir.
Into the 8 would go 4. 2 into 6 would go 3. This would be 4 over 3. And as a ratio, 4 to 3. So not what we want. Okay. 5 to 12. We have anything that can go into both 5 and 12? Highest
Sir?
common factor? 1. So
Yes.
this is already in lowest terms. Can't go any further than that. To 8, reduce. 2 into this would go 3 times 2 into 8. So
4
2 into the
times.
6, 3, and 2 into 8, 4. This is what we're looking for, because if we take this fraction and turn it into a ratio, we'll get 3 to 4. We still go and test the last one, which is over 9. 3 can go into both of these. 3 will go into this 4 times, and 3 will go into 9 3 times. This is 4 upon 3. That can be changed to 4 to 3. Not what we are looking for. So option
Okay.
C, this one is equivalent to it.
To 3, 3 to 4.
Okay.
Yes, sir.
Read that one for me.
16 over 5 written as a mixed number is, sir, 3 and 1 over 5, sir.
All right, let's see. How do I change? What is this?
So an improper fraction.
Okay, so 16 over 5. How do I change a improper fraction to a mixed number?
Sir, divide the 16 by the 5.
5 into 16.
3 times, sir.
3 5s would give me 15. When I subtract, I get 1.
1. The
So
remainder,
what is the 3?
the
The
whole number, sir.
Okay, 3 as the whole number. The remainder becomes the what?
What the numerator,
And the divisor is the?
denominator.
Excellent. 99 in Roman numerals.
Sir, medical Xavier.
Medical Xavier. Let's see if we can fill the scene. 1,000,
500,
500, 100, 50,
10,
10,
5,
5,
1.
1. So how do we get the 99? Let's break this. 90 plus 9. What represents 9?
Sir, LX, sir.
LX. L is 50.
No, sir, no, sir.
X.
IX, IX.
Okay. So IX. So what represents our 90?
Sir, um, XL? No? Is it? Sir, am I not going to?
What represents 100?
Sir, C, sir.
What represents 90?
Sir, E- LC.
No, X.
Oh yeah, XC, sir, XC.
So 99 is actually what? XCIX.
Yes,
So XCIX.
I.
What does this mean again? In the Roman numeral system, if we have a digit or a symbol rather of lesser value to the left of a symbol
Left.
of greater value, then we are subtracting. So this is actually what? 100, and we are taking away from that 10. That's how
10.
we get the 90. Again, we have 10 and we are taking away what? 1. Okay?
Yes, sir.
So that's how we get to our 9. Of
Yes,
course,
sir.
some people are going to say that this really should not be written like this. It should be XCIC.
Sir, my butt is at 14,
Okay?
13%.
All right, let's hurry now. 17% as a decimal would be what? So 17%
Sir,
is actually
17
17
over
over 100. So this will be equal to
0.17. Yes, sir.
so 0.17.
Sir,
So we have 2 places here, 2 zeros here. So we need 2 places. Which is a multiple of 2, 3, and 7? Which of these is a multiple of 2, 3, and 7?
sir, 27, sir.
You can multiply something by 7 to get 27.
Oh, no, sir. No, sir. Sir, 42, sir.
So if we were to use prime factorization, for example, 12, 2 could go into the 12, what?
6
6.
times
2 could go into the 6,
26, 3 times
3. 3 could go into 3, 1. So
1.
4, 3, 2, 6, 6, 2 is 12. So we have the 2 and we have 3, but we don't have any 7.
Well, no, 7.
So 12 is out of it. All right, let's go with 21. 3. 3 into the 21, 7 times.
7,
7 into
7,
7.
7, 1.
So we in this one, we have the 7 and we have the 3, but we don't have any 2. So this one is out of it. 27.
7.
3 into 227, 9 times. 3 into 9, 3 times. 3 into 3, 1. In this case, we only have what?
3.
As a factor there, and we don't have the 7 as a factor there. Let's look at 42. So 42, I can start with 2 because this is an even number. I get 21. Now I can go to what? 3. 3 into 21, 7. 7 into 7, 1. So here I have 2, 3, and 7. So this says to me that I can multiply something by 2 to get 42. I can multiply something by 3 to get 42. And I can multiply something by 7 to get 42.
Yes, sir.
878 in expanded form.
Sir, 8 times 100. 7 times 10. 8 times 1.
All right. This is how we got the 800. This is how we'll get 70. No. Let's go back. Yes. Let's see if we can find our place. No, past that one. And finally, 8 times 1 will give us the 8. We add all of that together, we get back the 878. Again, this is just a what?
So
Expanded notation. and we have to know our place value.
Sir, 10%. What?
10%? Where?
Sir,
Oh,
on
the
my
battery. Okay. All right, let's go. 1 dozen mangoes costs $120. What is the cost of 8 of those mangoes?
Sir, 120 times 8.
Really?
Sir?
All right, so you say
Oh, no, no, sir,
120
no, sir.
times 8.
No, sir, no, sir. That's not going
So
to.
one of these mangoes would cost how much? $960.
No, sir.
And we said here that all of the 1 dozen would be costing 120.
No, sir.
So first we need to work out how much one mango costs, not true?
Yes, sir.
So if 1 dozen of them costs $120, what is the cost for one?
Sir. Sir, no. The 1 dozen mangoes cost. Oh, sir, what is the cost?
So here I have something on the screen that might help. 120 divided by the number of mangoes, 12. 12 into itself, one time, 12 into 12, one, carry back my zero, $10. So each mango would cost $10.
$10.
Now they ask me for the cost of what? 8 of those mangoes. So if I know one costs 10, then 10 times 8 will give me what?
80, sir.
Okay, so it's $80 for 8 of those mangoes. So it's just simply reasoning it out and making the association with what? A dozen as compared to the 120 for the cost of all of the dozen versus what one of them would cost. So the key here is being able to identify what they call the unit cost. All right.
Yes, sir.
All right, let's go before that phone battery finish. What unit is used to measure oil? Is it Celsius,
Sir.
kilogram, kilometer, or liter?
Liter.
All right, so we did some of this in class today. So liter is the unit used to measure volume. Okay, meter, distance, gram, weight. Celsius would be used to measure what? Temperature. What time is on this clock?
Sir, 2:30, sir.
2:30 is correct. We are past 2 already, and we are heading to 3, but we're not there yet.
Yes,
All right,
sir.
so 2:30. So that's it for tonight. Thank you guys for joining.
Yes,
especially
sir.
those watching on the replay. All right, prepare for your exams, and we'll see you in the next episode.
Yes, sir.